So remember, Chapter 5 had 10 different lessons, so a lot of information is in Chapter 5. What you see here on the practice test will be very similar to what you're going to see on the test, okay? So just so that you keep that in mind. Now, again, we're going to start this now, and then we'll continue this on our next Google Meet. So let's start with 1 through 3. 1 through 3 says, choose the term that best describes the shaded part of the trinomial. So where the 2 is listed here, that is a coefficient. Anything that is in front of or multiplied by an x term would be considered a coefficient. Where the 2 is located there, that is considered the degree of the polynomial, so that's A. And then finally, on the end here, a constant term is where you just have a numerical value that you're adding or subtracting, so that's considered a constant. Okay, just very simple there. And now let's move on to some ones we want to calculate. Okay, so let's take a look at 4, 5, and 6. Now, as we're doing these, you really want to keep in mind your order of operations. So please excuse my dear Aunt Sally. We want to do inside parentheses. We want to do exponents. We want to multiply and divide from left to right. We want to add and subtract from left to right. So keep those things in mind. When we do a problem like number 4, the first thing that we need to deal with is the exponents that are on those, because inside the parentheses, there's nothing for us to simplify. If there's something inside a parenthesis to simplify, simplify it first and then move outward. Well, this is really going to be 5 to the 4th, e to the 4th. That's our first piece. And our back piece is going to be 6 squared times c squared. Now, 5 to the 4th you can think of as 25 squared, or 25 times 25, or 5 times 5 times 5 times 5, however you want to do it. So that's 625. And then this is 36. And then it's common and customary to simplify it far enough down that you have one coefficient in front, and then your variables, it's a good idea to keep them in alphabetical order just so then you can really keep track of everything. And so 625 times 36 is 22,500, and then we would have b to the 4th c squared. So that's as far as we can go. Unless the power on your numbers are super high and ridiculous, you can physically multiply those out. And you will be able to use a standard calculator on the test. Let's move on to number 5. Number 5, when we have 2 terms multiplied by 2 terms, it's going to require us to do distribution. So we're going to take the 13x and distribute it. Then we're going to take the -1 and distribute it. So let's start with our 13. If I distribute the 13x, I am left with 13x squared plus 39x. And now I'm going to distribute the -1. I'm left with -x minus 3. Now you're not done until you physically combine any like terms. These 2 terms there are like terms. 39x minus x gives me a total of 38x. The 13x squared and the -3 just come down for the ride because there's no like terms to change or combine there. It is customary to put that in descending order, our highest power, then the next, and then the next. So try to keep your final answer like that. So there is 4 and 5. Let's move on to number 6. So if you see any power outside of something with more than one term, my suggestion is to write it down however many times you see it. So if I see the power is a 3, I'm going to write it 3 times. Now the reason I'm going to write it 3 times is to remind myself that I need to actually physically FOIL that out, distribute that out. So I'm going to focus first on these two. I'm going to distribute all of that and get an answer for the multiplication of those two. And then I'm going to multiply the answer on the back. So if I multiply the first two, I'm going to get 4h squared minus 12h. Now all I did there was distribute the 2h. Now let's distribute the negative 6. We're going to get negative 12h plus 36. Now don't move on to the next step until we have combined like terms. So those two are like terms. So instead of writing it as negative 12 and negative 12, just combine those and make that a negative 24. Now, once we get to this point, this quantity cannot be changed. This quantity can't be changed. So now it's time to distribute again. Now this time we have to distribute 3 times. We're going to distribute this one over here. We're going to distribute this one over here. And then finally we're going to distribute that one. Okay, so we have 3 distributions to do. If we distribute the 4h squared, we get 8h cubed minus 24h squared. Okay, now all I did was distribute that over there. So you get 8h cubed minus 24h squared. Now we're going to distribute the negative 24. Okay, that's next. We're going to get negative 48h squared, because h times h squared. And then 6 times 24 is 144, and negative times negative is a positive 144h. Okay, so that's 24 times negative 24h times 2h, negative 24h times negative 6. Okay. Next we have to distribute the 36. We get 72h minus 36 times 6, which is 216. Okay? Now, usually in this big long list, now this doesn't always happen, but usually in this big long list there are some like terms. So the 8h cubed is its own unique thing, so just write it down. Now let's move to the square. We're going descendingly. Negative 24 and 48, negative 48 is negative 72h squared. Now we have a 144 and a 72. So those are like terms, and we can add those up. And then finally, the 216 is its own unique creature, and so it comes down for the rod. So now let's do 7 and 8, and 7 and 8 are about scientific notation. So when I do a problem that deals with scientific notation, what I tend to do is I tend to pull out the regular numbers and multiply them together. And then I pull out the scientific notation part and bring those together, because it will just help you make sense of it all when it's, as we go through the problem. Now, if you do the 3.16 times 24, you get 75.84. Now, 10 to a power of 3 times 10 to a power of 2. If the bases are alike and you're multiplying, you keep base and you add up the exponents. So that would be a 10 to the 5th. Now that's pretty much the answer, but Scientific notation says that our front number should always be a number between 1 and 10. And because this number is too big, we need to modify it. So how do you modify it? Well, if you want to move the decimal place over 1 to the left, and your number was bigger than 10 initially, however many places you move it, you're going to add 1 on to the power. And so I'm going to move that decimal back between the 7 and the 5, and then my power is going to become a 10 to the 6th. So that is a scientific notation that's multiplication. Let's do number 8. Now, they all started out as standard decimal numbers. Let's just do the multiplication and division in a calculator, and let's see what our calculator tells us. So if we do 7,200,000 times 0.0011 divided by 0.018. The calculator reads 4,400,000. Does it read 400? Just a second. Oh, no, it's only 440,000. Me and my decimals, goodness gracious. Anyway, that's 440,000. So how do we put that back in scientific notation? Now remember, we want a number times some power of 10, and our number in front should always end up being some number between 1 and 10. And so we want the decimal to go right there, so we want to change it to 4.4. Now what power would we put on? Well, if this original thing was more than 10, our power will be positive. If the original thing was a number less than 1 or less than 10, you're going to have a power that's negative. And so this is going to be a positive power. We're going to take, and we have moved our decimal place 1, 2, 3, 4, 5 places to get to the spot we want. So that would be 10 to the 5th. So if your decimal place moved to the left, to counteract that, we need 10 to a power that is positive. So there is 7 and 8. Now, problem 9 and 10 is about division. We learned 2 types of division. We learned division just by long division, and we learned division by, I can't think of the name. We'll get to the other kind of division we used with the little box. Okay, I don't know why I can't think of it right now. But anyway, synthetic division, there we go. So let's do number 9 using long division. Let's do number 10 using synthetic. Okay, we'll do one of each. So the first thing that you check when doing long division, let's check our powers. They go 4, 3, 2, 1, nothing. So that means that we do not need to put any 0 placeholders, and that is sometimes a possibility. You're going to put your x minus 2 out in front. We're going to put our remaining, what we're dividing into, inside. And now remember what we're going to do. We're going to compare the first 2 and say, what would we multiply x by to turn it into x to the 4th? And that would be an x cubed. And so since it's an x cubed, I put it above the x cubed spot just so that it lines up and goes down the line nicely. It kind of tells me naturally where to stop then. Now, remember what you do with this thing you put up here. We're going to distribute it to both of the things outside. So if we multiply x times x cubed, we're going to get x to the 4th. X times negative 2x is negative 2x cubed. Put a little line underneath. We are subtracting, so change the signs of both, and then combine like terms. So this term should go away. X to the 4th minus x to the 4th is nothing. Negative x cubed plus 2x cubed is a positive x cubed, and bring down the next thing. And we're going to do it again. Now we compare these two. What times x is going to give me x cubed? That's going to be x squared. It's put on top. We're going to distribute. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. We are subtracting, so change the signs of both and combine like terms. These two are gone. Negative 2 plus 10 is negative 8x squared. Bring down the next thing. Now we're asking ourselves, what times x will give me negative 8x squared? And that would be a negative 8x. Put it on top. Now we're going to distribute it. When we multiply it by x, we get negative 8x squared. When we multiply it by negative 2, we get positive 16x. Put your addition line. We are subtracting, so change the signs of both. Negative 8 plus 8 is 0, so that first term goes away. 4 minus 16 is negative 12x. Bring down your last term. Now you ask yourself, what times x will give me negative 12x? That will be negative 12. Put it on top. We're going to distribute that to both things. So that's going to be negative 12x plus 24. We are subtracting, so we're going to change the signs of both. Whatever's right here is our remainder. We don't have a remainder, so our answer is this exact value here. Number 10 is we're going to do it using synthetic division. Now, how do we do synthetic division? Well, we definitely want to make sure that this should be a plain old x for us to proceed using synthetic division. It is a plain old x. We're ready to go. We're going to set that divisor equal to 0, and we're going to solve for x. And so we get negative 2. And negative 2 is going to go into our corner box. Whatever you get after that, you're going to put in our corner box. Now let's check what we're dividing into. Our powers should be descending. Our powers go 3, 2, 1, nothing. It's perfect. What we're going to do now is we're going to write down the coefficients we see that are attached to our variables. So there's a 2 on the first one, then a positive 9, and a negative 2, and a positive 7. Between the last two numbers, put a little kind of divider line. Make yourself a space and put an addition line. Whatever your first value is, bring it down. Now that's just the setup of our box. But you're going to set up the synthetic division box like that every time. Now let's actually do the math. So we're going to multiply what's in the box with whatever's underneath, negative 2 times 2. We're going to write it down. We're going to add them up. So 9 minus 4, or 9 plus negative 4, however you want to look at it, is 5. We're going to multiply, write it down, add them up. We're going to multiply, write it down, add them up. Okay? Now, the spot in this corner is our remainder. So we do have a remainder for this one. Now, let's think about our x's. We started out, this was an x cubed. Use that little arrow here to remind you, okay, my power is going to go down by 1. So this is going to be x squared. And then it's going to go down the list, and it's just going to go x to the second, x to the first, x to the nothing, or no x's, and then the remainder. Let's see how we write this. Well, our final answer is going to be 2x squared plus 5x minus 12. Now here's how you write the remainder. If the remainder is positive, put a plus. If it's minus, put a minus. Put your remainder on the top of a fraction, and the bottom of the fraction will always be whatever your divider is. So our divider here is x plus 2. So we're going to put it over x plus 2. So that's division. Next, let's do 11 through 13. 11 through 13 is asking us to factor completely, as much as you can. If it is not factorable, we're going to write the word prime. Okay? Okay, let's start with 11. We are looking for the factors of 45 that add up. Now, the reason it's going to add up is if this piece is positive, that add up to 14. Okay? So the way that you're going to do it is we know for sure that when the back sign is positive, just look to the middle, and that sign repeats both times. Now let's break down the number 45. 45 and 1, 3 and 15. Well, the one we're looking for actually is 9 and 5. 9 times 5 is 45, but adds up to 14. Now you should always check to see if there was a common multiple we could have removed initially. There wasn't. You should also look to see, are these quantities factorable any further? If it is not, we're done. So there's number 11. Let's look at number 12. Number 12 is kind of a unique one. The reason I think it's kind of unique is we have both R's and P's. The way that it's going to work is there's going to be an R on this side and a P on that side. That's the only difference. The numbers are still going to work the same way. To me, this is a classic candidate for slide and divide. Okay? Now, if you recall my slide and divide, I'm going to take the 2, not the R, but 2, and I'm going to slide it over. Okay? So I'm going to pretend like my problem was R squared plus 3PR minus 4P squared. I'm going to pretend like it's, so the 2 goes over and slides over and becomes a 4. Well, how does that factor? Again, it's going to be R's and P's, so don't worry about that part. But how is it going to factor? Well, if this back sign is negative, you automatically get a plus and a minus. Now, we need the factors of 4 when the back sign is negative to subtract to give us 3. Well, for 4, we only have 2 choices, 4 and 1 or 2 and 2. 4 and 1 is the one that subtracts to give us a value of 3. So what do we want? Well, we want the 4 to be positive so that it matches up with that middle sign. That bigger number should be on the middle sign, whatever the middle sign is. And our other number, the 1, is going to go here. Now remember how slide divide works. You slide it over, and then you divide it off. So I have to divide by 2. If it divides by 2 like this first piece, divide it. So I know that this is R plus 2P. If it doesn't divide or reduce, like this one, just take whatever's left in our denominator and stick it on the R. So this is going to be 2R minus 1P. You don't have to write it like that. So our final answer, so I can fit a 2, I'm going to erase that out. 2R minus 1P. And how can you check? Well, to check division or factoring, if you remultiplied, you should get what you see there. Okay? Now, I'm not going to give you one like 13 on the test, but I will show you how it factors. It's really actually a kind of cool problem. This factors to be x plus the square root of 3 and x plus the square root of 3. How do I know that? Well, it's just a pattern that appears when the two things match like this. What do we get? A square root of 3x plus the square root of 3x is 2 of them. Square root of 3 times square root of 3 is 3. It just happens. So you can write that down, but I'm not going to do one quite using square roots just yet for the test. So there's 11, 12, and 13. Let's see how many we got here. So let's go ahead and do the next. What time is it? Let's go ahead and stop. We'll continue this where we left off. We'll continue it when we meet again on Tuesday. So assume that we're going to do this again together on Tuesday, and it's not going to be due till Tuesday at midnight. Okay? So that is it for today. Thanks so much for watching. If you want to start reviewing for the chapter test this weekend, that'd probably be a good idea. Okay, bye guys. Have a good one.